Hello, ladies and gentlemen. This is Unit 7, Day 3, and we are solving for missing sides of right triangles. Because really, that's all we're dealing with, are right triangles in this unit, because, well, trigonometry only deals with right triangles, right? So anyway, in the last lesson we saw how to use our calculator to evaluate the trigonometric ratios and how to use these sides of a right triangle to determine an acute angle. Okay, and so let's view the process first. So given the right triangle shown below, set up a trigonometric ratio involving A, that angle there, and use it to find the measure of A to the nearest degree. Okay, so we're going to have to use our inverse trig functions. Okay, and basically what it is we take that ratio, we put it in our calculator, and it actually gives us the exact angle measure that goes with that particular ratio. Okay, so remember in all these, right, for trigonometry to work, okay, it involves all similar right triangles, right? So in this particular case, okay, we need to figure out what ratio we get when we utilize those two sides, and then see if we can match that ratio up with our inverse trig function, right? And let's see if that makes sense. So anyway, hopefully I didn't just confuse you guys. So let's just figure this out, all right? So talking about measure of angle A, right? So this would be our opposite side, this would be our adjacent side, and this is our hypotenuse, okay? And so what we first have to think about is which trig function can we utilize in order to, or which trig function are we going to utilize to figure out our ratio here, all right? So which trig function involves our adjacent side and our hypotenuse, right? Well, that is cosine. So the cosine of A is equal to our adjacent side over our hypotenuse, okay? So that being said, we're just going to plug in the pieces that we know. Shrink this down a little bit. Okay, so we don't know what the measure of angle A is, but we know these other two pieces, 17 over 22. Okay? And so what we're going to utilize is we're going to utilize our inverse function of cosine. And what that does is it matches us up the ratio we get for this guy here with what our angle measure should be when we're getting this particular ratio, right? So the inverse cosine of 17 divided by 22. All right, so the measure of angle A is 39.4000, whoops, 56. So let's round it to the nearest degree. So A is 39 degrees. So what we just found is this, that based off of what our calculator has, it states that for any angle measure of a right triangle, right, or for any right triangle that has an acute angle of 39, its ratio created by its adjacent and its hypotenuse, okay, for any right triangle, right, that has that degree measure, 39, okay, the ratio created from that angle, from its adjacent and hypotenuse side, is always going to be, well, in this case, around 17 divided by 22, whoops, which is about 0.7727. Okay, because if you typed in the cosine of 39 degrees, what do we get? Cosine of 39 is actually 0.77714. Okay, so the closest ratio we have to a degree measure would be the ratio created by the angle 39 degrees. The ratio created by the cosine of 39 degrees. Okay? All right, so in your calculator, right, this is the value that it has saved. Okay? And so for any right triangle that has a 39-degree measure there, okay, it's adjacent over hypotenuse. That ratio created by those two side lengths will always be right about there. And the closest one we had to the ratio we had down here was 39 degrees. Okay? So anyway, if we have two sides of any right triangle, then either of the acute angles can be found using the inverse of trigonometric ratios. But even more importantly, if we have the measure of an acute angle in any of the sides, okay, then we can use trigonometry to find the length of any side, or evidently any angle as well. Okay? So in exercise 2, it says, in each of the following, quickly solve for the value of x. Okay? So we just have to be prepared to see some problems like this, right? So in order to solve for x here, whoops, I'm going to multiply both sides by 6. So x is equal to 30. Here, I'm going to have to multiply both sides by x in order to get that x out from underneath the denominator. And then x is equal to 6. So same thing here. Multiply by a, x is equal to ab. And over here, multiply by x, ax, whoops, x is equal to bx, gosh darn it, a is equal to x, and then divide by b, and x is equal to a over b. Okay? All right, so nothing too trivial there, just kind of reminding you of how to solve single-step problems, or in this case, B and D are multi-step because we had to take a couple steps there. Okay? So if you can solve these, you can find the missing side of a right triangle very easily. Right? So in the following diagram, one of the acute angles is given in one of the legs. And so solve for each of the other sides of the right triangle. Okay, so it wants us to find MP, which I will label X, and NP, which I will label Y. Okay, and so let's take a look at these two sides here. Now, because we're only in reference to 36 here, okay, we're not going to have to adjust any of these particular sides, right? The X will always be the opposite side, your Y will always be your hypotenuse, and the length 28 will be your adjacent side. Okay? So it says for the length of the side of MP, right, we're asked to find that. Okay. So you have to think about this for a second. Which one of our trig functions involve our adjacent and opposite side? Well, that's got to be tan. So 36 degrees is equal to our opposite over adjacent. Okay? So, again, our calculator already has that ratio in your calculator. So for any right triangle that has an acute angle of 36, okay, in reference to that angle, the ratio created by that opposite and adjacent side is going to be 0.726542. Okay? Now, we don't know what our opposite is, so I'm going to put the x there, but our adjacent side is going to be 28. Okay? So there's some number x, such that when I put that number in there, it'll create this particular ratio. Right? The ratio for the tan of 36 degrees. So, in order to find that, well, we just multiply both sides by 28. Okay, and then x is equal to 20, this is round to the nearest tenth, 0.3. Okay, so this guy is now 20.3. All right, and then it says solve for the length of Pn. Okay, so then we have to think about, all right, which trig function involves our adjacent and our hypotenuse? Well, that's the cosine. Okay. Now again, there's already a ratio in your calculator for the cosine of 36 degrees, which is anytime you have a triangle that has an acute angle of 36 degrees, the ratio created by its adjacent and hypotenuse side in reference to that angle, okay, is going to be 0.8090169944. Okay? So what we're looking for now is there's some value of y such that when I take this adjacent side and divide it by this hypotenuse, okay, the ratio I'm going to get is going to be this guy right here. So in order to find that, I'm going to multiply both sides by y and then divide by that really long number. So y is equal to 28 divided by 0.8090169944. So you divide all that out. This says round it to the nearest tenth. So y is equal to 34.6. Okay? And that's the ratio, or that would be the length of the side that we would need to create this ratio right here. Okay? So if you check it out, right? 34.6, I'm sorry, 28 divided by 34.6, and we get just about that number on the left. All right? Which is the ratio you get from the adjacent side over the hypotenuse side of a right triangle with acute angle 36 degrees. Okay? So let's head down to the last bunch of examples here. Okay, so it says keys to solving for the missing side of a right triangle. We know one side and an acute angle, which as you can see down here in example 4. And then the next step is set up the proper trig proportion using angles and sides. Okay, so in number 4, it's asking us to find the length of BC. Okay, so in reference to 24, BC is our adjacent side, and 18 is our hypotenuse. So again, which trig ratio involves our adjacent and hypotenuse? Okay, well that's got to be cosine, right? And so we don't know what the adjacent is, so I'm just going to put an x there over hypotenuse, which is 18. Okay, and so what we're finding here, what we need to find is the cosine of 24 is 0.91355. Okay, and this is the ratio you get for when you have a right triangle with an acute angle of 24. Okay, the ratio created by this side and this side here will always be what you see there, 0.913555. So we have to find what number, okay, will make this statement true. So in order to do that, I'm going to multiply both sides by 18. And by doing so, okay, we get x is equal to 16 and to the nearest tenth, 0.4. So the length of this side, 16.4. Okay, the next one, all right, talking about an isosceles triangle. Okay, I'm trying to make one the best I can here. Not too bad. Okay, so the height, so an isosceles triangle has a base of 26 inches. Okay, and has base angles that measure 64 degrees. Okay, and we want to know, okay, determine the height of this isosceles triangle. Okay? And so remember, these heights of isosceles triangles, right, pretty much, well, not pretty much, they divide these, the height of an isosceles triangle, okay, drawn in, will divide the isosceles triangle into two congruent right triangles, okay? And so they want to know is what is the height of this guy, okay? So remember the height of isosceles triangles is kind of like the, not only does it bisect this angle up here, right, but it also bisects these two sides as well, okay? Which isn't, well, it is very important because if this whole piece down below is 26 inches, that means that when we chop this guy in half, this will be 13 and this will be 13. Okay, so now we have everything we need, and then we just need to find this missing piece right here. Okay, so depending on how you want to look at it, right, I'm going to look at this guy over here. So this will be our opposite, and this will be our adjacent side. Okay, so we're going to go the tan 64 degrees is equal to our, well, our opposite over adjacent. Okay, and then we just solve. So multiply both sides by 13. Okay, so 13 times the tan of 64 is equal to x. And so tan 64 times 13, x is equal to 26.7. Okay? And then this says in the length of its legs to the nearest tenth. Okay, so they want to know what the hypotenuse is. Okay, so we're just going to have to switch up our we'll just have to switch up our our ratio. Right, so I'm going to go, we'll just call this guy y up here. So we're going to go, let's see, so this is our adjacent and our hypotenuse. So the cosine of 64, because I want to find what my hypotenuse is going to be 13, and in this case is going to be y. So I'm going to multiply both sides by y. So I get y times the cosine of 64 is equal to 13. Divide by the cosine of 64. Divide by the cosine of 64. Okay, so we get y is equal to 13 divided by the cosine of 64 degrees, and the ratio created by the adjacent and the hypotenuse side of 64 degrees, 29 point, the nearest tenth, 7. Okay? Which makes sense because, well, that hypotenuse leg should always be the longest side of the two. Okay. And then the right triangle PQR, draw it in here. Okay, there's our right triangle. So Q is the right angle, R is 48. So PQR, okay. PQ is 11. So it's asking us which of the following expressions correctly evaluates PR. So they want to know, so this is our opposite, this is our adjacent, this is our hypotenuse. So which one of these expressions correctly calculates the hypotenuse? All right, so let's see. So we're going to have to go cosine 48 is equal to our, ooh, we don't want to use cosine because we don't know what our adjacent is. How about sine? We haven't used that one in a while. Sine of 48 is equal to the opposite over our hypotenuse. So in this case, sine of 48 is equal to 11 over, in this case, x. And so if we wanted to find what that is, I'm going to multiply both sides by x. So x times the sine 48 is equal to 11. Divide by the sine of 48. Divide by the sine of 48. X is equal to 11. Divided by the sine of 48, which is right there. Okay? So, anyway, hopefully this sort of helps. We will continue to work through these, you guys. And good luck.